Hello, I'm Phil Archer from the W3C, where it's my job to work out what standards are missing to enable better use of the web as a platform for sharing data. In January 2017, one of my working groups completed this document, Data on the Web Best Practices. On the platform, the link to this document is provided. It covers many of the issues raised in this course and is designed for engineers. If you're sharing data on the web, whether openly or not, the document amounts to a checklist covering things like metadata, licensing, versioning, use of HTTP URIs as identifiers, data quality, vocabularies, and APIs. In short, how to make your data discoverable and reusable. But it's not complete. It can't be. There's too much to say, and it's designed as a very general document. One of the areas that is not really covered in any detail is spatial data. The spatial data on the web best practices, provides more detail about this crucial area of open data. Why is it crucial? Because so much data is related to location, and often it's the location that is the thing that links different data sets. On the platform, also, the link to this document can be found. My aim in this talk is to help you become familiar with the key aspects of spatial data. We'll talk about spatial things, coordinate reference systems, and more. See where to find existing HTTP URIs for locations, and talk a little about how to provide metadata related to location. Let's start with the concept of a spatial thing. That is, anything with spatial extent. That is size, shape, or position. For example, people, places, bowling balls, as well as abstract areas like administrative areas, or even something that isn't real at all, like Shakespearean London. That raises an issue to do with spatial data straight away. Whenever you talk about place, you also need to talk about time. The Spatial Data on the Web Best Practices document gives the example of the Eddystone Lighthouse off the southwest coast of England. Now, a helicopter pilot might see it as a vertical obstruction and be interested in attributes such as its height and precise location, whereas a sailor may see it as a maritime navigation aid and need information about its light characteristic and general location. In truth, it's both a navigation hazard and a navigation aid, so be careful not to exclude potential users of your data by only presenting it as one thing. And where exactly is this lighthouse? Well, there are lots of ways of answering that. Here's one. It's a bit of GeoJSON, and the location is given as a point. That's simple enough. But that's not how you should refer to the Eddystone, because geometries are dangerous. First of all, there are many ways you can describe the same geometry. The point, 50.184 degrees north, 4.268 west, probably describes the center footprint of the lighthouse. But you could just as easily provide a set of coordinates that define the 2D polygon of that footprint, or of a 3D volume. There is no single correct geometry for a location. Also, whatever I may measure as the central point, you may remeasure it and come to a different answer. If you define an administrative boundary by its geometry, you're very likely to find your data becomes out of date very quickly. Local and even national boundaries change remarkably frequently. And there are two more reasons why geometries are dangerous ways to refer to locations. Continents move. Australia is moving north at about 5.6 centimeters per year. Europe and the US are diverging at a similar rate, so that locations given as lat long can at least become inaccurate. Now, being 5 or 10 centimeters out won't matter for a lot of applications, but for others it can, and over time it will. Finally, in many situations, geometries and maps in general can be very political, as you'll notice if you look at a map of Ukraine or Israel. So, how do you refer to the Eddystone Lighthouse? Remember, we're talking about spatial data on the web. so you refer to it like this. That's a URI for the Eddystone Lighthouse, provided in this case by the German National Library. And if you follow that link, you'll see this web page if you use a browser, or this page if your user agent asks for RDF. The important thing is that you have an identifier for the spatial thing, and then you can attach one or more geometries to it. Both the general Data on the Web Best Practices and its spatial cousin emphasize the value of using URIs as identifiers. It's how we're building the global web of data. As we've seen, the German National Library is one source of stable, persistent URIs that you can link to and use in your data. Other national libraries, including France, UK, and Sweden, are among other large-scale users and providers of linked data. For geographical features, GeoNames is a good bet, with over 11 million place names, and its free-to-use database. DBpedia, the linked data version of Wikipedia, and Wikipedia's own Wikidata are also good sources of stable, persistent URIs, and some national mapping agencies also make some or all of their data available as linked data. I want to turn to a topic that geographers and cartographers worry about a lot. Here's a map of the world you may have seen before. It's the Gall-Peters projection that, unlike the much more commonly seen Mercator projection, gives a more accurate view of the relative sizes of the Earth's landmasses. A quick search of the web will find other projections and maps showing how big Japan really is or how small Greenland is, and so on. And if you can change the projection, what happens to things like latitude and longitude? The irritating fact is that the Earth is not flat. Worse, it's not a perfect sphere. And worst of all, continents move. For all these reasons, mapping agencies who create very accurate maps don't use latitude and longitude. Now, lat-long on the Mercator projection is fine for the vast majority of applications, and on the web, that's what you'll find. But if you're working with data from a mapping agency, beware. They will almost certainly be using a different coordinate reference system with an origin typically just off to the southwest of the mapped area. For lat-long, 0, 0 is off the west coast of Africa. If you're using a Dutch map, it's actually southeast of Paris, near La Salle Saint-Cyr. Finally, metadata. This course has a lot to say about metadata, so I don't need to go into a lot of detail here. But if you're publishing a data set, if it relates to a place or a region, and very many do, then it's important to make that clear. Users will very often find your data by looking for data about a place. So how do you refer to location? By using a stable, persistent URI or a short string that can be turned into a URI, such as those provided by GeoNames, DBpedia, national mapping agencies, and libraries. You'll find URIs for countries, regions, towns, postcodes, and so on, and then there are URIs for regions to which government statistics are applied. These are known as NUTS codes in Europe. And using these URIs links your data with everyone else's data about the same place. To help guide you in providing metadata related to location, the European Commission has produced an application profile of the W3C data catalog vocabulary known as GeoDCAT-AP. That sets out terms for including location in metadata about data sets that may or may not be primarily spatial in nature, such as lists of available services and amenities. If your data is spatial in nature, air quality for example, then the spatial data on the web best practices highlight further aspects, such as the coordinate reference system, the spatial resolution, and maybe the bounding box of the area covered, and so on. The number of metadata standards is bewildering. As the saying goes, metadata standards must be a good thing, that's why there are so many of them. So you certainly have a choice. However, do choose a standard, rather than making up your own way of doing things. One of the things we're doing in the VRE for EIC project is to help bridge between those standards. In this talk, we've looked at some of the key concepts of spatial data. how to identify spatial things, and why that's not the same as saying where it is. I've emphasized the use of stable, persistent URIs for identifying locations so that different data sets about the same location can be linked across the web. And just now, we looked at including location in metadata. All these aspects are covered in much more detail in the OGC W3C Spatial Data on the Web Best Practices that, in turn, builds on the more general Data on the Web Best Practices. Before you share any data, I recommend you become familiar with them both.